let's go to the number 3 programming challenge for chapter 5. Within this one, we will talk about how many tosses before you run out. So from our coin. So for this one, so we will read the challenge later. But before that is if you watch the earlier video, is I just update you is I already link the programming names into the specific chapter and the subchapter. So all the programming, the Python program with our rocket icon. So that is our real program. So this program actually is in if you go to the GitHub, it's inside the GitHub here. And if you refresh it, we keep adding that. But in GitHub, I only put in the same level. Using the mind map, I hope to give you our network that you can quickly go through which the program is linking to which knowledge point. So that is the thing is I'm trying to update to you. And then this, let's go to our book. So for this challenge, let's consider simple game. Play just the fire. It's a fire, so which means it's the uniform distribution. It's not the non-uniform. So a player win $1 if got heads and loss $1.5 if got tail. So game is over when the player balance reduce 0. And for our program, we gave our starting balance or starting amount specified by our inputs. And our program will try to play these coin toss and calculate the updated amount. And when the outstanding amount is reach 0 or below 0, then this game is over. And then we will print out is what are the every step of those playing, like this one. Give this toss result, then the outstanding the balance. And when the game is over, we give our message, and we start starting line with the beginning amount. So this, if we consider from the programming perspective, first definitely we need the random. And here is if we see the just 0 and 1 to represent heads and tail, then we can use the integer random. So rand int. So that is one. Second one is we will need to make our list, and no need a list. We need a starting amount, and we need to count every times the result, and either increase or decrease based on the heads or tail. And because we cannot foresee the how many times we will finish the game, so it's not suitable for using the for loop. So we will choose the while loop. So then we will define a function to do the play, and through our primary program is to code this function. So if we have these high-level ideas, let's start today's from scratch. So now let's have this 0, 5. Oh, this is the 0, 5, 0, 3, and the numbers 3. So the toss coin toss game. So let's make to that. So we have this one. So and let's see the purpose. Coin toss game, which will be over when the player balance reaches $0. Okay, so definitely we need random. So that let's make that first. And if we put our play as our game, and let's go to none first. Then let's, sorry. So what we will do is we will ask a user to give our beginning amount. So let's say the start amount equal to, let's say it's if user gave our the float is fine, so we don't need to identify that is only our integer. So we can use a float input. Please enter the starting amount. And then we will make the play. So what the play is, we will transfer this starting amount. Then we know is here we have our starting amount. And we have this start amount, then we will starting to make this program. So what we will need is first is we will have to define. So if win, so then that means the tail. So we see the maybe it's a head amount equal to +1, tail amount is the minus. We can use the just we can use the subtract, so we can see that is loss. I think it's better is we use this minus here, so then we know this is loss. Then we put this the outstanding amount. First, we initialize that equal to start amount. Then is we have our tosses. Those numbers of the tosses initialized at 0. Then we can start to have our while loop. While what? While is the outstanding amount still the more than 0. So if that is more than 0, then we still can continue do the game. Then while this more than 0, what we will do is we will do the toss. And what will our toss? Toss is the let's see is the random dot int either 0 or 1. So then once we make a toss is the tosses equal to tosses plus 1. So this you can also can write also as tosses plus 0, 1. So that is the same way, but I just make that more clear. So we will try to see. So if we see the toss, then we see toss is either 1 or 0 or 1. So we will make a definition. So we will see, because it's a uniform distribution, we can define whatever. So head refers to toss equals 0, and then tail refer to toss equal 1. So then if we have this is if we know if toss is 0, then we know it's actually is a head. If this head is our outstanding amount, we will use this plus equal head, right? So and then this we will print. So because we want to print every the result, intermediate result. So print this head is the hard code, so heads. So then current, always see the outstanding amount should be better. Amount. So now we have our 0. We give .1f, and then we go to the format. What's this is outstanding amount. And then similar is else. Else, that means is tail. So outstanding amount, because I define this as the negative, so I can still use this plus 0. So we put that difference in the beginning. Then here you can see the this code is quite nice. So now is tails. And outstanding amount is outstanding amount. So once is the loop is finished, then that means outstanding amount is not more than 0. Then I can print the game over. So game over. Give our the cry face is this one. So like this. And then the outstanding amount, we see the final things. And then coin tosses. So that is the 1, so it can be the integer, so tosses. So we have that count as a counter. So every time is we make this toss plus. So let's do so. Run. So tosses. So tosses. So let's see. So tosses is not defined. So we have this. ES. Oh, so here is we should use toss. And then the no, it's tosses, I think. But it's defined from here. So let's run this again. So in module TOSSES. So let me see here. TOSSES is go to the number 1. So format with this dot format tosses. Tosses is equal to 0. So I think it's I have defined this. That means I should use this only. It's strange, so I cannot use tosses equal to tosses plus 1. Okay, so these are strange things. Let me. So because here is 0 and it's read 0. Next time is tosses is yeah. Let's just run this again. So let's give a 10. Okay, so now sometimes I win a lot. Maximum go to 13. But finally, so that is a gambling. So it's also our lessons learned is don't try to play gamble or casino. So finally you will lose all. So even if you have a lot money, so maybe I give if you have 1,000, so very quickly you will lose all the things. But before that is before you lose to 0 until 0, you are exciting playing is 4,000 times. So looks like you are trying to win, but finally is you will lose. So even if you put that quite large, but you can see you are quickly lose and until the nothing left. So those are the This quick game, but this one I think is interesting. So I still think I should be able to use this way. So otherwise, oh, so let's see. So 20. Oh, maybe it's the issue is I haven't completely saved. So that is also, but again, I should say is that this is the foundation way. So if you use the this plus zero equal or the minus equal, that's the simpler way. But you need to remember this is the standard way. It definitely should be correct. So. And then I hope is you also get your play on the running. Sometimes you can play the 5 times of your beginning amount, but finally you will lose. So game is will be the finished because when you lose every time you lose the amount more than when you win. So that is if we adjust this sometimes is also the back end of our casino. The department, the company, they will adjust this from backend. Then they can let you feel more exciting to do the playing. But yeah, game is just a game. So let's back to our learning. So I hope is you get this knowledge point from the this code. Next video we will do this shuffling a deck of cards and to see what we can learn from that part. See you next video.